Hi everyone, in this video I'd like to talk about the period of a trig function. And to do that, I'd just like to start off with an example and then we'll get into the definitions. So if I gave you a function like y equals 3 sine of 2 pi x plus 4, this would give us a lot of information. So the number in front of your trig function there, this 3, this would be the amplitude. So I'm going to label that A. So A is our amplitude. And in that particular equation, it's going to be 3. Next, let's take a look at this 4 that's hanging off the back end. That's going to be our vertical shift up. And I'm going to label that D. So I'm going to skip a few letters here for a minute. You'll see why. So this is the vertical shift, and in this case, it's going to be up 4. Now, the period is related to the coefficient in front of our x, which is our b term. So b is going to be this number right here. That's not our period though. So this is 2 pi. And the connection here is that period, which is the length of time needed to complete one cycle. Okay, so that's what period is. Period is related to b, it's not equal to b, and the relationship is this: period equals 2 pi over b. Okay, so if I wanted to know what's the period in this particular example, I need to do 2 pi over b. In other words, I need to compute 2 pi over, well, this one's 2 pi. So my period should be 1. Every 1 unit, I get a full cycle of my sine curve. All right, there's also something called C, and I'll come back and give you an example about that in a minute. So that's our horizontal translation or our horizontal shift. And in this case, we don't have anything. And if we did, it would be right in there. So let's take a look at this graph, and then we're going to come back and look at some more complicated examples with the period and what this parameter b is doing in our life. So I'm going to hop over to Desmos. So I'm over here in Desmos, and just for fun, I'm going to plot my regular sine curve. This is the one we know and love. So in this case, b is 1, and so my period is going to be 2 pi over 1. In other words, every 2 pi units, I get a full cycle of my sine curve. And I could trace that out here. I start at 0, and I go all the way around to right here. There's one cycle, and that's 2 pi units. That would be the period. All right, now, we're not interested in that. We were interested in a more complicated example. So we had 2 pi in here. Notice that my curve oscillates more frequently. My period, we said, was 1. So let's take a look if that's true. Notice I go up and down. I've completed one full cycle when x goes from 0 to 1. So in that time span of 1 unit, I got a full cycle. And we computed that over in our drawing. All right, now let's add in some of our other parameters. We had a stretching factor of 3. We had an amplitude of 3. So notice that brought my peaks and my valleys up, the max and the mins up to a 3 and down to -3. So that was good. And then we had a +4 off the back end, which was a vertical shift of 4. So I slid the whole thing up on my graph. And I can recenter myself here. Okay, now let's take a look at another example, but one that's a little bit more complicated. So I'm going to make a little bit of space for us here. But I'll keep all our definitions here. I'm just going to change the numbers in our problem. Okay, so new problem. This time I would like to look at the example y equals 2 sine pi x minus 2. I'll make that a 3 actually. Just so we don't have 2's floating all over in our problem. That would be a bit much. And I won't have any d value off the end there. I'll make that 0. All right, so let's go through. Amplitude we know is the number sitting out in front here. That's our 2. And off the back end, the vertical shift was essentially plus 0. Yeah, so that's our d. Now, I've saved the b and the c last because I need to do a little bit of computation before I can tell you what my b and my c really are. So what I need to do here is I need to write this as pi parentheses x minus, I'm factoring out a pi, 3 over pi. And I need to do that because that's my b value is sitting out in front of the x. I know that I slid my x over. There's a horizontal translation, but it would be wrong to say that I slid over 3 units, and I'll show you that in the graph. But my b is pi. So in this case, my b is pi. B is pi. And my period now, always the formula is 2 pi over b. So I'm going to have 2 pi over b. In this case, b is pi. So my period is going to be 2. And now my horizontal translation is going to be 3 over pi. And that's going to be 3 over pi units to the right. So when I'm thinking about what 3 over pi would be, you know, that's about 1, like pi is like 3.14. So this is going to be about 1 unit over to the right. And I have my s in the wrong place. Let me fix that there. All right, so let's hop over to Desmos and we'll take a look at that graph because I think that will be very informative. Okay, so we're back in Desmos and let's just start off nice and gentle here and build up our model. So first of all, y equals sine of x. Okay, everything's working. That's lovely. Now, in this problem, we had a pi x. Okay. And we have, let's see, pi x minus 3 in there. And we had a 2 out. We had a 2 out in front here. So there is our graph. So let's notice a few things here. First of all, we claimed that the period, we said that the period was 2. So let's confirm that that's the case. First of all, I can see, if I graph my regular sine, let's say of pi x function, you can see that the red line there does go up and down and back around. It takes me 2 units to do that. All right, so that is correct. We had a period of 2. The next thing we said, and we want to check if that makes sense, I said there was a shift to the right of about 1 unit. We said it was 3 over pi. Now, let's take a look at that. So if I were to graph y equals sine of pi x, notice that the blue line is my y equals sine of pi x. Notice that the purple line is kind of like the same thing, but it got shifted to the right 1 unit. Instead of that 0, 0 being my like midpoint where I'm going to start oscillating and going uphill, now that starting point is shifted over 1 unit to the right by about 1. I think it's through, very, very close to 1. So we go up and down and around. And then, of course, we had the amplitude of 2, and we can certainly see that with the 2 and the minus 2 for my maximums and minimums. Okay, now it would have been tempting to look at this equation here and think, oh yeah, I have a shift to the right of 3, and that would not be correct.